Welcome to Math 105, Chapter 2.3, where we are working with your Excel sheet and building a few equations. So we talked about annuities in this chapter. We are making either a series of withdrawals or deposits over a specific time, which is called an annuity. So we might have accumulation or withdrawals. And we have a few different formulas to enter in. We have about 4 here. So once when your payment is known, but we are talking about accumulating, so gaining money, so gaining a future value. Or in this case, it's the opposite. We don't have your payment, but we do have the future value that we might want to gain towards or go towards. And then we talk about withdrawals, where we have your payment and okay, it just says, okay, well, if this is our given payment, what do I need to have right now? Or the reverse. If I have something right now, how much do I need to have in my account? What payments should I be making? So those are the 4 that we're going to be working with today. So it says, in example 1, at the end of each month, you deposit $50 into an account earning 2% annual interest compounded monthly. Find the future value after 5 years. So let's have you pause the video and put in this information into the following equation. So we said we have $50, that is your deposit, right? When it talks about deposit versus withdrawals, if you deposit something, you're putting money into it in order for the account to grow. So we are trying to grow to this future value. So we have $50, which we will make into a dollar amount. We have 2% interest, and it's annual interest compounded monthly, and we have 5 years. We have this annual interest and the year, which match in units, so that's good. We now have compounded monthly. We have R times T, so we've done that one before. M times T. We have R divided by M. Now we want your future value. So your future value is this whole equation here. It says equals your payments times parentheses. We might want to open up another parentheses. You'll see it right here, because our first parentheses on the inside, we'll do this calculation. Then the next, we'll do the subtraction with the 1. And the last one, we'll do the parentheses with the division. So we actually want to have 3 open here. And every time you open, when you look at your screen, when you close it, it should flash in the color that we've now closed your parentheses. So you have 1 plus, and then it says R over M, which is this value here, raised to the M times T, so this value here. And you'll notice that each time I close, it's flashing that it's closed, minus 1, parentheses. And then it says divided by R over M. Do that one. So we should get out 3,152 and 37 cents. Now, if you wanted to, you certainly could add another parentheses to do the division here. So if I were to show that one more time, it would look like this. Notice that it doesn't change. So let's go ahead and change this into a monetary value. We don't need so many decimal places, so I might reduce a little bit. And of course, maybe some flares. So let's try it again with example 2. Find the future value of a $200 deposit, $200 being deposited quarterly. So that changes this amount to quarterly for 18 years at 2% per year. So that one stays the same. Now notice that it's this dollar sign. Notice that your answer is going to be very large. It just means that this cell is too small. So let's go ahead and expand. And you'll notice that those answers match up. So now let's try it again when this time you don't have your payments, but you have a future value amount in mind that we want to grow to. So it says find the periodic payments necessary to accumulate to $20,000. When it means to accumulate, right, it means to grow. So to grow into this $200,000 investment. Make sure that I have enough zeros here. No, it's 20,000, not 200,000. So 20,000. Again, let's talk about some monetary values. We don't have your payment. This is something that we're going to have to find. We have your rate, which is 6% per year with monthly payments for 5 years. Again, your rate and your time units are the same, so we don't have an issue. So let's go ahead and try this one out. So now let's hit equals. Now it says future value times, and I'm going to open up maybe 3 parentheses again. So maybe 1, 2, 3. Yeah, that should be enough. So it says R over M. So this would be this amount here divided by parentheses. And actually, now that I look at it, it may be a little bit too many parentheses, but I'll just make sure to close each and every one. Actually, before I do so, maybe I just delete up here. Delete 1, 2. All right, so just 1 parentheses. Okay, there we go. So parentheses, 1 more parentheses, 1 plus, let's do R over M, raised to the M times T. Let's close that parentheses. Oh, and notice that I did not open enough here. So let's do 1 more parentheses at the beginning. That way, when I subtract from 1, it should close that one. So all in all, if I were to start over, let's see, I want 1 initial. So 1, 2, 3 down below. So let me try that again. Equals future value times your rate over your compounding divided by, let's see, 1, 2, 3. Let's see, 1, 2, yeah. 1 plus R over M divided by that. There we go. Minus 1. There we go. And that last initial. So I'll pause here just so that you can verify that this is what you have. So we want to make about 286 and 66 cents deposit in order to gain $20,000 in your bank account. There you go. Now let's try it again with withdrawals. So see if you can pause on this one. We're going to be working on example 4. So see if you can pause and try it again. So it says at the end of each month, you want to withdraw $50 from your account, earning 2% annual interest compounded monthly. You want to you want the account to last for 5 years. What is your present value? And we haven't talked about it before, but there are 2 types of annuities. One that you compound at the end, or one at the beginning. Their equations are nearly the same. You just have an extra compounding period at the beginning, versus at the end, you don't have an additional compounding one. So if you were to use the annuity do, your equation would change ever so slightly. So it says equals, oh, sorry, not equals. We have to actually put values in. So we are now talking about withdrawing money. So withdrawing from something that you have currently. So we'll talk about withdrawals in present value. So your rate is 2% per year. Your time is 5 years. We have 12. M times T is equal to R divided by M. Your present value, we have this equation up here because we're talking about the end of each month. We're doing at the ordinary and ordinary due. So we have equals your payment times, and I'm going to open up 3 parentheses. So we have 1 minus parentheses, 1 plus R over M. I'm just right here or right here. Close parentheses. Raised to the negative M times T. Close parentheses, therefore we subtract. let's see, divided by R over M, and close one more. So I opened one extra parentheses that I shouldn't have, but that's okay. We're just going to close them both. So we should get 2,852 and 62 cents. Let's have you try it one more time now with withdrawing given an unknown payment. So we have something that's, we have a present value in mind, and we want to know how much can I take away from it. So what payments would it be to get to the account to perhaps 0 or a particular number we have in mind. So it says, what is the amount of money that should be withdrawn each quarter from a $100,000 college education fund, earning 4% annual interest compounded monthly or quarterly in order to get the account to 0 after 4 years? Perfect. So we don't have your payment. So this is something that we don't know. We do have your rate. So it says 4% annual. We have over 4 years, compounded quarterly. We do have R times T, let's see, M times T, R divided by M is equal to, or sorry, your present value, we have 100,000. Let's put that into, all right, 100,000, perfect. So now we're going to be using this equation here. We want to know, what do your withdrawals have to be? So you hit equals, and let's hit your present value times one parentheses open here to start, R over M, divided by, let's do 1, 2 parentheses. So we have 1 minus parentheses, 1 plus R divided by M here, raised to the negative M times T. Close your parentheses, and then close the one to bring it all together, and then one more. So you'll see this is the equation that I have from above. And switch it into a monetary value. All right, and that is it. We can certainly use the goal seek for these as well. Keep in mind what your known and unknown values are.